Okay, I'm showing how these LEDs are turned off and on using our Keyestudio control board ESP32. This board has many stacks, these female headers, and we can use them to plug in LEDs. In this case, I've got a resistor that is going through the ground wire to all 5 of these LEDs. Now the thing to keep in mind here is if you plug in certain LEDs, they'll glow brighter or not at all. This is something that's not mentioned in the tutorial for the Keyestudio ESP32 board. I've got it running with Bluetooth, that's what this is. Called light blue. And light blue controls this board, sends signals to turn LEDs on and off depending on the code that's written. And I will show you something regarding the brightness of the LEDs. You can see that the red is brighter than the yellow. Yellow is more dim, and that is true of these other colors. And I'll talk for a minute about resistors also. So I asked ChatGPT, do small voltage 3.3 volt to 5 volt LEDs draw the same current regardless of color? No. Okay, it's important to ask your question with enough detail that ChatGPT understands what you're trying to find out. That's the reason I mentioned low voltage on resistors, LEDs. So they give me back a reading on the different voltages that are required to make an LED glow depending on color, and clearly the red one is going to glow the brightest with the least amount of voltage, and the blue and white are going to require more forward voltage, they're calling it, in order to make this glow, and then it explains why in more detail than I would have ever wanted. Okay, so now I'm going to go back and show the resistor issue. When we get our resistors, in this particular case, the instructions, the tutorial calls for a 220 ohm resistor on these LEDs. Otherwise, they will burn out if they don't have a resistor in the circuit. So these LEDs come in different resistances, also called ohms, and usually that's with the Greek symbol omega. But here you're seeing that when I came out of the box, they've got an R after them instead of the omega symbol. I used a 680. I didn't have a 220 immediately available, and I knew that 680 would work. It would be more than enough to reduce excess voltage on the little LEDs. It will not allow them to burn out. However, it may be more than required, 680. How do you know if these come out of the little tape? How do you know what the resistance of this resistor is? Well, it's got these lines that are stripes that are different colors and different orders, and technically you're supposed to be able to figure out that this is 680 ohms, even though based on these lines. It's a lot easier if you've got a little device like this, very inexpensive, that measures your different resistors and other, because it's got a battery. It measures your resistance of the resistor and gives you a readout. $753.8, pretty close to 750, and it even identifies it as a resistor. Very useful little tool. Rechargeable, got a battery on board. All right, where did I get the code to make this work? The code I was using earlier today in Arduino, which I'm no expert, identifies these libraries which come with the Adafruit group or library pack, which they tell you to download, to select and install. And then earlier today I did a single LED pin and it was labeled just LED pin 1. That was the variable, or pin, LED pin variable on digital pin 26. Digital pin 26 is going to be marked on the board. And what I did was I went back and changed that variable LED pin to LED pin 1. Then I added 2 more pins, just duplicated exactly what they had written. LED pin 25 and 17. The reason is there aren't any numbers between 25 and 17 in these vertical stacks. That's why I chose 17. Then every place where it says, where it refers to LED pins, as in pin 1, 2, and 3, I labeled them all as outputs, so the microprocessor knows we're talking about outputting to these pins, pin numbers. And then I chose a call equals, they had pin on and pin off. I changed that to pin 1 and 2 because I'm talking about these 2 pins being high and pin 3 being low, and then I changed it to off for my typed in amount. That's what I'm typing to send from the app to the board by Bluetooth. Type in OFF12 and that sends a signal for pins 1 and 2 to be off and pin 3 to be on. First thing I did after making these changes is run this check to make sure that I don't have any errors. That compiled all right. It took a long time to compile, but it did. And then I did download. Then I went to the app, and this app is a little bit confusing to get through all of these, settings in the app. I haven't learned all that yet. This explains your settings, but it doesn't do it verbally. It just does it with arrows, which makes it a little more difficult. They're giving us all our code that we need and just explaining why we're using this code, which is one important reason for using this board. We can use all kinds of sensors and outputs, and we have explanations on and on and on about how to write the code for them. Hopefully we'll eventually be able to use this Wi-Fi chip to upload data to ThingSpeak on the web. So there will be more about this.